Hi, I'm Christine. You just heard from Jordan about how CSO is a major problem. Now let's talk about how we can use design as a solution to reduce combined sewer overflow in the Gowanus Canal. Look familiar? You may have some green space or a garden at your school, but picture it, you probably have a lot of paved areas like this. And where does rain go when it falls on pavement? It runs off and it all ends up in the sewer system, overflowing in our waterways along with the wastewater from toilets and sinks. This is called combined sewer overflow, or CSO for short. 100 years ago, the combined sewer system was a good design. It prevented polluted water from backing up into people's houses and into the street. But today, that means a simple playground like this becomes part of our water pollution problem for the Gowanus Canal and other waterways around New York City. So what can we do? What if school campuses could be part of the solution rather than the problem? In this design challenge, we're going to ask you to reimagine your school campus with green space, but not just any green space. You're going to be designing green infrastructure. Let's see how it works. When it rains, water falls on streets, sidewalks, parking lots, and rooftops. This water can then be redirected into engineered systems like this bioswale, where plants and soil absorb the water. This prevents water from going into the sewer system and causing CSO. Get it? Green infrastructure stops or slows down stormwater before it goes into the sewers. Let's look at some examples of different types of green infrastructure. Here's a green roof. On a typical school roof, rain falls, enters a gutter, and goes into the sewer. If you had a green roof, plants and soil soak up the water. Some green roofs are just plants, and some, like this one, can also be a place to learn, play, or relax. Okay, let's see another type of green infrastructure. Here's a fun one: permeable pavement and permeable turf. This is a way to convert surfaces you walk or play on so they can absorb water. With permeable pavement, water trickles down into the cracks between the pavers. Same with permeable turf. It absorbs the rainwater, which trickles down into a drainage system or soil underneath. And what does permeable mean? It just means that water can pass through or permeate it. If something is impermeable, water runs off. Water cannot be absorbed or permeated. You'll be using that word a lot during this project. Here's another type of green infrastructure. A rain garden is exactly what it sounds like, a garden that captured rain. A rain garden is always located at the bottom of a slope. Rain runs down the slope and puddles in the garden. While it may look like the garden is flooding when it rains, the water will get absorbed over a day or two. If you notice a place that puddles or floods often, it might be a good place for a rain garden. Here we have two more examples. A curbside rain garden is the same idea as a rain garden, but it's located on a city sidewalk on the curb. Another name for this is bioswale. The rain runs down the street and into this little opening called an inlet. Plants and soil absorb the water, and any overflow comes out of the outlet and goes into the sewer. Bioswales can take up to 2,000 gallons of rain per storm, so most of the water will get absorbed. And here's a street tree. Trees are important small green spaces to absorb stormwater, and we have a lot of them. In fact, New York City completed an initiative to plant 1 million trees. That's a lot of water that can be absorbed. It's pretty simple. Trees soak up the water that falls on top of them, and some rain from the sidewalk. In this image, volunteers are taking care of a street tree. They are pulling out weeds and removing trash. The more we take care of street trees, the better they can act like a sponge for rainwater. Lastly, we have a rain barrel. In this design, water runs down the two sloped sides of the roof and into this gutter. Water is stored in the barrel, which can then be used for other purposes, watering a garden or washing a car, for example. This is called a rainwater harvesting system because you're saving rainwater for another use. The larger the roof or catchment area, the more rain you can catch per storm. Now you have a better idea of the different types of green infrastructure, though these are just a few options you'll be working with. You can also research other types of green infrastructure and get innovative. So, why should we design green infrastructure? We know it stops or slows stormwater and reduces CSO. What are the other benefits? Less CSO means less pollution in our waterways and cleaner water. It also cools our urban heat island. Pavement on a summer day is hot, right? Plants cool the air. That's important as we think about rising temperatures due to climate change. Plants also take in CO2 and breathe out oxygen. Cleaner air means less people have asthma, a major public health issue in our city. More plants mean more habitat for birds, bees, and other helpful pollinators. They need food, nesting material, and a safe place to live. And last but not least, we can beautify our concrete jungle. Nature makes people healthier and feel calmer, which we definitely need when things get stressful. These are all called co-benefits, meaning green infrastructure has multiple benefits. Okay, who's in this design challenge? Here's a map showing the Gowanus Canal, the blue line in the middle. Students from 3 schools will be creating proposals for your school campus: Brooklyn Collaborative Studies, MS447, and MS88. We asked your schools to be in this challenge for an important reason. You're all located within an area called the Gowanus Sewer Shed. See this dotted line? It represents the area that adds CSO to the Gowanus Canal when it rains. All CSO goes to a waterway, and yours goes to the Gowanus Canal. Have you guessed by now why we're calling it the Blue Schools Design Challenge? Any green space you create in this sewer shed area will mean a cleaner, bluer Gowanus Canal. Are you ready to start the design challenge?